In this video, we're going to be taking a look at some constant velocity graphs. We have 5 different vehicles exhibiting 5 different types of motion, and we're going to take a look at what those look like on a position versus time graph, velocity versus time graph, and acceleration versus time graph. Our first one is completely at rest with no velocity. The second one, it's moving to the right, it's moving forward, so this one has a small positive velocity. The second one has a large positive velocity. And then now we have two objects or two cars going in opposite direction. So we have one with a small negative velocity and then one with a large negative velocity. Now let's start with our object at rest, which is going to be the easiest case. Now, if you don't have a starting position, you don't actually know where to place it on a position versus time graph. So I'm just going to go ahead and place it right in the middle here. All we know is that it's a line that has no slope. That means that it's sitting at a particular position, and then as the time runs, it's staying at that same position. So any sort of flat line, whether it's at the top of the graph or the bottom of the graph, would mean that it's at rest because its position is constant. If it's not moving, then its velocity is definitely right on 0 meters per second for the velocity time graph. And because there is absolutely no change in its velocity, the acceleration is also 0. Now, taking a look at the car with the small positive velocity, that means it's moving forward at a slow rate. Now, because we're talking about constant velocity graphs, everything on a position versus time graph has a straight line because it has a rate of change that is constant. So if this one is moving forward at the same exact rate, then it would have a constant positive velocity shown with a constant positive slope. Now, when you take a look at the velocity time graph, we aren't changing the velocity because remember, this is constant velocity, constant meaning it's staying exactly the same. So a constant positive velocity would look like this, showing that it has the same velocity of, we'll say, maybe 2 meters per second, remaining the same the whole entire time. And now, because it is at a constant velocity, the acceleration is 0, which means no change in its velocity, which means it's just not speeding up or slowing down. And then now heading to our green arrow over here, this one has a larger positive velocity. Okay, again, this one is constant, so it has a constant positive slope, but has a greater slope. It's steeper, showing that its position changes more so than the orange one in a smaller period of time, showing a greater positive velocity. So you're always looking for a steeper slope. And then because it's a greater constant positive velocity, then we have a line above the orange one. And then for the acceleration versus time graph, again, we are right on 0 again because there is no change in its velocity. It's not getting faster or slower. Now, taking a look at the cars with a negative velocity, that means that they are exhibiting the same sorts of speeds, but in a different direction. So these ones are starting from 0 and moving in the positive direction. So these ones are moving towards the origin. So these ones would be up here and then slanted back, sort of like that. Okay, again, we don't really know the starting position, so this could be starting over here or over here. It doesn't really matter. The focus right now is showing that a small negative velocity is going to have a fairly shallow negative slope. Now for our velocity versus time graph, we're going to go under 0 and show a small negative velocity by staying fairly close to 0 and keeping it nice and constant. And again, for all of these graphs, there is no acceleration because there is no change in the velocity. Now going to our very last one, when we have a greater negative velocity, that means we have a greater change in negative position. So we are starting up here, but then moving backwards more and more quickly. It'll look something like that. Now, some people ask, is it moving backwards? It could be moving backwards. You could call it a car moving in reverse, but it could just be facing the other direction as well. So it really just means in the opposite direction. So we're starting a little farther away and then moving back towards 0. And it has a steep negative slope because it has a large negative velocity. So this one would be under the blue line, farther away from 0 to show a greater negative number. And then we're going to have no acceleration for this one as well. So to sum things up, when you're taking a look at the position versus time graph, these are the things you're going to be paying attention to. You're going to be paying attention to, is it going in the positive direction? Is it rising up on the graph? Is it going to be going in the negative direction, getting lower on the graph, or is it staying at rest and being completely flat and showing no slope? Now, our speeds and our velocities are going to be shown with the steepness of the slope. Remember, steepness means more vertical. So even when comparing positive and negative slopes, the one that's more vertical is going to be traveling faster. And then with the velocity versus time graphs, they're all going to be perfectly flat lines to show that they are maintaining a constant motion. If it's not moving at all, it's on zero. And then anything above zero is going to show a positive velocity, which means it was rising up on the position versus time graph. And then the other way around for the negative velocities, if they're underneath, that means that was moving backwards towards the origin. For all these graphs, we have an acceleration of zero, which means that the velocity isn't changing. It doesn't mean it's going faster or slower, it just means it isn't increasing or decreasing speed. So I hope that was helpful in helping you understand and draw position, velocity, and acceleration time graphs for constant velocity. Thank you for watching.